Hi there, Serdar Yegilalp here for InfoWorld at IDG. In this episode of Smart Python, I'm going to look at some of the new features coming to Python in version 3.10, slated for release later this year, and now available in beta test form. The biggest new feature, and one that's been long awaited by Python users, is structural pattern matching. Many languages like C have had what's called a switch case syntax that lets you elegantly choose one of several actions to take based on the value of a variable. Over the years, various attempts have been made to add this feature to Python, but they've always been rejected because they were more or less redundant with other ways of doing things. Now, other languages like Rust have expanded on the basic idea, and they let you take actions based on whether a given variable matches a pattern, such as one of a number of possible type expressions. In Python, as of version 3.10, we now have the ability to match a variable based on various patterns that the variable might be consistent with. The syntax for a pattern match is a match keyword that defines what to match against, and one or more case clauses that describe each match. In this example here, we take input from the user, break it into a list with the split function, and then match the resulting list against a number of different patterns that might come from it. Some of these patterns, like quit, consist of only one element. Some, like load, are more than one, in this case a command and some argument that goes with it. With the pattern write/export, we're using the logical OR operator to indicate that either of the patterns described there will match this particular case. The final case with the underscore, that's a wildcard that matches everything after all other options have been exhausted and lets us take some other action. Now I should say that this is only the tip of what's possible with structural pattern matching. It's meant to be much more than just a substitute for writing long chains of if, elif, else statements. To get a full and detailed rundown, check out the article on structural pattern matching linked in the video description. Another big feature in 3.10, also long awaited by Python users, is more precise error reporting. This is thanks to the rewritten parser now in the Python interpreter. The rewritten parser arrived in Python 3.9, and in 3.10 it's now being used to deliver much more robust error messages than before. Here's a quick example. Let's take some obviously incorrect code. Note that we have a missing parenthesis, which our linter is actually flagging ahead of time. If we switch to Python 3.9 and try to run it, the error we get tells us something is indeed wrong, but the error message is slightly misleading. It tells us there's invalid syntax at the start of a line that's actually valid. It's not very helpful. The real mistake is one line before. Now let's switch to the 3.10 interpreter and run the code again. Note how now we get a far more precise error. It's warning us exactly of what went wrong in the exact place. We forgot to close this specific parentheses. More detailed errors like this make working with code a lot more elegant in 3.10. A third major development is around the way type annotations work in Python. This is something that's been growing with importance with each passing revision of the language, as more Python developers add type annotations to their code where it makes sense, and Python's own typing annotation syntax becomes more robust. Python's typing module, which is used for providing type annotations, lets you describe the types of a callable, like a function. But that type information can't be propagated across callables. This makes it hard to annotate things like function decorators, which take in one function and return another one. In this example, which I've taken from Python's own documentation of how this works, I have a function called addLogging, which works as a decorator. It takes in a function with a specific signature, in this case a number followed by a string, and wraps it in a function that adds logging. The problem is that our type annotations for the decorator are imprecise. They don't let us indicate what kinds of arguments we can propagate to the wrapped function. We're just passing them along as is, and we're not able to check them. As a result, if we run this code, the second instance of the takesIntString function will fail because we're passing into it argument types that don't match. And the linter is not catching this either, because all of the type information is being erased as it passes through the decorator. Now let's take a look at the same code, but with one of the new typing annotations available in 3.10, paramspec. Paramspec lets us indicate where to capture positional and keyword arguments, so that the types of the arguments can also be correctly propagated through the decorator. Now, our second erroneously typed function instance does get caught by the linter, which is as it should be. The first one, which has correct types, is okay. If you want to try out Python 3.10 now, you can download a copy of the first beta from python.org. You should note, however, that until Python 3.10 is officially released, it should be considered beta software and not used in production. But by all means, give it a whirl in a controlled environment and see how your existing Python 3 projects run with it. That's it for this video. If you liked it, please leave a comment below. Don't forget to subscribe to the IGT Check Talk channel on YouTube. For more smart Python and more dev with Serdar, be sure to follow me on Facebook, YouTube, and Infoworld.com.